Good evening, everyone. Welcome to NPTL tutorial session on the course Classics in Total Synthesis taken by Professor Krishna P. Kaliappan from IIT Bombay. Myself, Sreelekshmi. I am a PMRF research scholar under the guidance of Professor Krishna P. Kaliappan, Chemistry Department, IIT Bombay. So, this is our 10th NPTL tutorial session, and let me share my screen. So, as in the previous sessions, So, as in the previous session, we will be discussing some assignment questions, previous week's assignment questions, and basic idea of the last week's lecture content also. So, maybe we will wait a couple of minutes and see whether anyone is joining, and then we can start. Okay, so first we will be starting with the discussion on week 8 assignment. Then we will move to the discussion on a brief summary on the last week lecture contents. And then, if there is time, we will try to discuss the week 9 assignment as well in today's session. So, moving to the first question of week 8 assignment. Identify the major product in the following transformation. So this particular compound is treated with CH3COMe thrice and this EtCOOH, that is a carboxylic acid, and under reflux condition. So what will be happening, and out of the four options given here, which will be the major product in this transformation? So I will give you some time to think about this. So here the correct answer is option D. That is, nothing has changed, just this double bond has migrated to here and this ester group have came at this position, at the terminal position. So what is happening here is actually a Claisen rearrangement. So we have previously discussed the mechanism of Claisen rearrangement as well. So by treating with the CH3C, this trimethoxy compound and this carboxylic acid, this hydroxyl group will be converted into this corresponding ester group, not ester like this kind of compound, and then it can undergo a Claisen type of rearrangement. Like this bond will be shifted to here, this will become a C double bond O, and this will be attacking to this position. So basically this bond is breaking, a carbon-carbon bond is forming between these two carbons. So we will get this product as a result of Claisen rearrangement. So I hope it is clear. In the presence of this compound, here this hydroxyl group get converted into O, C, O, M, E, double bond, CH, double bond, CH2. And because we are heating and there is a possibility for this Claisen rearrangement, it will undergo this 3,3 sigma tropic rearrangement to give this unsaturated ester. So the correct answer is option D. This is not alpha beta unsaturated ester, but the correct answer is option D. Moving to the next question, question number 2. What is the major product formed in the following transformation? That is, this triol is treated with this triphenyl phosphine and carbon tetrachloride and triethylamine. Out of these four options, which will be the major product and what will be the conversion leading to that particular product? So here what is happening will be, first this oxygen have a tendency to coordinate with this triphenyl phosphine, and then this chlorine from this carbon tetrachloride will replace that pph3o, and here in place of OH it will come chlorine, and then this nitrogen lone pairs will attack at this position and it will eliminate that particular chloride ion. So here will not be OH, here will be Cl minus. So we will get one additional 1, 2, 3, 4, 5, 6 membered ring. 6, right? 1, 2, 3, 4, 5, 5 membered ring. So which will be the correct answer? 5 membered ring. So option C will be the correct answer. That is, it is going through this. This hydroxyl group will be replaced by this chloride, and this nitrogen lone pairs will attack at this carbon, and Cl minus will knock out, and we will get this particular diol. That is, option C will be the major product. Moving to the third question, identify the major product in the following transformation. So, which will be the major product if we are treating this compound with toluene under reflex condition? We are heating this compound by dissolving in toluene up to reflex. So, what can happen? What will be the major product in this reaction? So here correct answer will be, or the major product is option A. So what will be happening here is, as we can see, first it will be forming a spiro kind of compound, that is this oxygen will oxygen from OH, that is carboxylic acid, that electron rich oxygen will go and attack this imine carbon, and it will form the spiro compound. And when the spiro compound undergoes rearrangement, it will get converted into this particular fused system. So this is the spiro compound is the intermediate. So what is happening here is, this nitrogen lone pair will attack at this position, and this bond will be cleaving, this bond will be cleaving, then it will result in 1 2 3 4 5 6. Hmm, I have to clarify that, but it is going through. I think sir have already discussed this particular example in the slide also, in the lecture also, week 8 lectures. So this will be the corresponding intermediate, and this pyro compound upon rearrangement we will get this fused compound. Yes, what I said was correct. That is, this particular nitrogen lone pairs will attack this electron deficient this carbonyl electrophilic this carbonyl carbon center, and as a result this bond will shift, and this bond will be get like it will get eliminated, or this bond will disintegrate, and this will result in 1 2 3 4 5 6 membered ring. Therefore from that spiro compound it will rearrange to give this corresponding fused system. So correct answer will be option A. This compound upon this toll will reflex through this spiro intermediate, we will get this compound A as a major product. Moving to the next question, that is match the following structures with suitable name. So here four structures are given and five compounds are given: disomorphin, codeine, thibine, morphine and galantamine. So you have to correctly match the structures and choose one option out of this four options given here. So here for this question, the correct answer is option D. That is, this particular structure corresponds to morphine. That is, here two are hydroxyl group, and the second structure correspond to B corresponds to galanthamine. That is, here is hydroxyl group as in morphine, but here is, as you can see, there is no hydroxyl group, and here at this position one hydroxyl group is there at galanthamine, and the position of double bond is also changed in galanthamine. Then this particular structure correspond to codeine, that is similar to morphine, but here instead of this phenolic group, here there is methoxy group. And then this last structure correspond to tibbe. That is, in morphine, if we replace both of this hydroxyl group with methoxy group, we will get the structure of tibbe. So these are the corresponding. First one is morphine, then the second one is galanthamine, third one is codeine, and fourth one is tibbe. So correct answer is option D. And this desomorphin structure is not given in this, out of this four structure, not, no structure matches with the structure of desomorphin. Moving to the fifth question of assignment 8, identify the transformation occur in the following. That is, this particular compound is treated with this potassium ferricyanide, water, and sodium bicarbonate. What will be the this product is forming, but we have to identify what is the reaction happening here. That is diene phenol rearrangement, open or oxidation, oxidative phenolic coupling, or Kulinkovich reaction. Out of the four reactions, which reaction is responsible for this particular transformation given here? So here the correct answer is oxidative phenolic coupling, and what is happening is that while treating this particular compound with this potassium ferricyanide in water and sodium bicarbonate, a radical will be generated. That is, this will become O radical and this will become O radical, and correspondingly here also one radical will be forming, and that will and this double bond will is getting homolysis. That is here also, and so this will be converted into this particular quinone and this will be converted into this particular quinone type of compound, and these two radicals will combine to give this particular product, and then this will be converted again, it will be rearomatized into this orthoquinone will rearomatize into aromatic ring, and this phenolic oxygen will attack this carbon, and here this bond will be shifted, and this will be shifted to here, and again it will be like this additional one furan type of ring is also forming, so we will be getting this product by this oxidative phenol coupling mechanism. So, as a result of this treatment with this potassium ferricyanate, radicals will develop here, here, and here, and here. So, this two will combine, and this will result in quinone type of systems. And once this get rearomatized into this phenolic compound, this OH will attack at this carbon, and this will attack here, and this will get converted into O minus or OH because water is also there. That is in an enolic form, and then it will again tautomerize into the stable alpha beta unsaturated ketone to get this product. So the correct answer is oxidative phenolic coupling. Moving to the next question, that is identify the major product in the following transformation. So here also this particular compound is treated with this potassium ferricyanide and K2CO3 in toluene water condition. Out of this four, which will be the major product? So as we discussed in the last question, it is clear that the mechanism will be oxidative coupling, and which will be the major product out of these four options. So here, as we discussed earlier, here also oxidative phenolic coupling is happening. That is, first this will be converted into quinone. Here one radical will be formed, and this will be converted into paraquinone, and here also a radical will be formed. So these two radicals will couple to form a bond here, and then this oxygen electrons will attack at this particular position, and it will result in this enol kind of compound, which will rearrange to form alpha beta unsaturated compound. So as in like this previous question, as we discuss here, like this one kind of intermediate and then coupling, and then this oxamical addition will be happening. So we will get this corresponding option C as the major product. So I hope it is clear, the oxidative phenolic coupling. So here also we saw the same reaction, and in this case also we are seeing oxidative phenolic coupling. Moving to the next question, that is seventh question. Identify the major product formed in this reaction given below. So this compound upon treatment with this aluminum chloride and CS2 under reflex condition, which will be the major product out of these four options. So here what is happening, it is just the Friedel-Crafts acylation, that is this. So the correct answer is option B. So this particular carbon will be attacked by this double bond in this fashion, and the Cl group will be eliminated. So we will get one, two, three, four, five, six. A six-membered ring will be forming. So this is the precursor for this particular chloride. That is, this acid chloride is made from the corresponding carboxylic acid, and this upon treatment with this AlCl3 CH2 and reflux condition, we will get this aromatic ring fused with this six-membered ring and five-membered ring by Friedel-Crafts acylation. Now the next question is, identify the major product in the following transformation. That is, this compound upon treatment with this tin chloride, hydrated tin chloride, what will be the major product in this reaction? So here what is happening is that this particular compound get reduced. This NO2 group will get reduced by this SnCl2 and hydrated SnCl2, and it will get converted into NH2, and then this enamine will also get hydrolyzed and it will form corresponding aldehyde. So this will be converted into NH2 and this will be hydrolyzed to form corresponding aldehyde, that is CH. C double bond O will be here. Then this nitrogen lone pair will attack that carbonyl carbon, and then like dehydration will result in dehydroxylation. OH and 1H will be eliminated from this position to give this indole derivative. So the correct answer will be option C. So I hope it is clear. First, this SnCl2, hydrated SnCl2 will hydrolyze this enamine to the corresponding aldehyde, and this nitro group 2 amine, and then nitrogen lone pair will attack the carbonyl carbon center, and OH and 1H will be eliminated. Dehydration will take place to form this compound. So the correct answer is option C. Moving to the next question, identify the major product of the following reaction. That is, this compound, first upon treatment with lithium aluminum hydride and second upon treatment with CbR4 and PPH3, what will be the product obtained? So here, as we know, first what is happening will be this lithium aluminum hydride is capable of reducing this ester into alcohol. So here it will be CH2OH will be coming. Then that Appel reaction will happen, and that hydroxyl group will be replaced by the bromine from the CbR4, which is helped by this PPH3, which can coordinate with the hydroxyl group, and we will get this hydroxyl group replaced with bromine. So the correct answer will be which one? Option A or option D? Option A will be the correct answer, because this tosyl group will not be affected by any of this condition, that is either LAH or CbR4 in presence of PPH3. will not affect the stosyl group, so it will be intact. Only change will be happening at this position, that is first it get reduced to CH2OH, followed by the conversion of that hydroxyl group into bromine. So we will get the correct answer as option A. Moving to the next question, identify the major product in the below reaction. That is, this compound upon treatment with hydrogen in palladium carbon condition in ethanol solvent, and this pressure is 30 psi, which will be the major product out of this four options. So here the correct answer will be option B. So what is happening is, first this, under this hydrogenolysis condition, this CpZ group will get deprotected and this will become free amino group like this NH2. Then this nitrogen lone pair can attack this carbonyl carbon and eliminate that OET group. So, OET group, and subsequently it can open this epoxide as well. That is next this, it will open this epoxide as well, and this will go here, and this epoxide will be opened from this side. So here we will get OH, and this will result in the formation of a 5-membered ring, and then 1, 2, 3, 4, 5, 6, a 6-membered ring fused with a 5-membered ring will be forming. So what will be happening? First this let's see, first this nitrogen lone pair is opening this epoxide. So what will be the intermediate? This corresponding compound will be the resulting intermediate. Then again this nitrogen lone pair can attack this electrophilic carbonyl carbon center, eliminating this OET group, and we will get this 5-membered ring fused with this 6-membered ring. That's this option A will be the major product in this reaction. So we have finished the discussion on week 8 assignment. I hope it is clear. Maybe I will give you some couple of minutes time to go through the assignment, and then we will start our discussion on last week's lecture contents. Okay, so I hope all these questions are clear. So now we will move to the discussion on last week lecture contents. So the lecture 45 was on Eastron total synthesis. First let us discuss a brief summary of that lecture. So this Eastron, in this lecture we have seen different approaches toward the total synthesis of Eastron utilizing double Heck reaction, 2 plus 2 plus 2 cycloaddition, multiport organocatalytic synthesis. And Eastron is a female sex hormone. The structure is given here along with estradiol and estriol. And it is a weak estrogen excreted in the form of estrone sulfate in urine. And as you can see, there are four contiguous chiral centers, and one angular methyl group is there, and the configuration is like trans anti trans configuration, that is anti trans anti ring junction, and trans hydrindane system. So this is the structure of Eastron. And total three total synthesis was discussed on Eastron, and the first one was Torgov synthesis, which was reported in 1963, and he completed this total synthesis in 6 steps. And the key reactions are acid catalyzed cyclization and stereoselective reduction. And the starting material was 6-ethoxy 1 tetrolone prepared from anisole. And then the other reactions which were discussed while discussing this total synthesis was Clemmensen reduction, Friedel-Crafts acylation, and then one stereoselective reduction using CBS catalyst, that is Corey's asymmetric synthesis. And then the next total synthesis was Taitsa synthesis, that was completed in 1996, which where the key reaction was double Heck reaction, and the starting material is Hajos Parish ketone in that total synthesis. Then another total synthesis was Volhard synthesis of Eastron, which was completed in 1980, utilizing a diene as the starting material, and the key reaction is 2 plus 2 plus 2 cycloaddition reaction. And the next four lectures continuously, we saw the discussion on Taxol, that is application of Shap. First total synthesis of Taxol was which was discussed was Nikolow's total synthesis, where we saw the application of Shapiro reaction and Pinacol coupling reaction in the convergent total synthesis of Taxol by Nikolow. And as you can see the structure of Taxol, it is a very complex structure having two six-membered rings, and this is the core skeleton having two six-membered rings, one eight-membered ring, and one five-membered ring. So it was isolated. This taxol was isolated from the bark of Pacific yew tree in 1962, and the structure was elucidated in 1971 by Wall and Warney through X-ray. And this compound has attracted the attention of many synthetic chemists over the last 2 decades. Has been successfully used for the ovarian and breast cancer treatment. Over 200 groups started this journey towards the total synthesis of Taxol. So far, only 10 groups have reached the shore. A single 100-year-old tree will result in 300 milligram of Taxol. This is just sufficient for one single dose for a cancer patient. Fortunately, in early 90s, it was found that 10-deacetyl baccatin 3, 10-DAB, a precursor of Taxol, lacking the C10 acetoxy group and C13 side chain in the needles and twigs of Taxus baccata, the European yew tree. And some analogs of Taxol like Taxotere, that is docetaxel, reported by Pierre Potier at CNRS, developed by Ron Paul and Rohrer, it is twice as active as Taxol. So in Nicholas' total synthesis, which was completed in 1994, the starting material was mucic acid. And the major synthetic challenges for the construction of this compound is highly congested searing with many chiral centers, 8-membered bearing, 686 carbocyclic system, and the key reactions involved are Diels-Alder reaction, McMurray coupling, and the starting material used is ethyl acetoacetate. And then the lecture 47 was about the discussion of first total synthesis of Taxol, that is by Holton, where we saw the application of epoxy alcohol fragmentation, Chan rearrangement, and Dieckmann condensation, the total synthesis of Taxol by Holton. And the first total synthesis was this first total synthesis was completed in 1994 before Nikolov synthesis. And this epoxy alcohol fragmentation has enabled the synthesis of bicyclo 531 skeleton of Taxol. And the other key steps involve Chan rearrangement and Dieckmann cyclization. Alpha acyloxy acetate rearranges under LDA conditions to give 2-hydroxy 3-keto esters and started with the commercially available natural product Pacino. And here in this total synthesis, he is also using Burger's reagent, and he took 46 linear steps to complete this total synthesis from Pacholin oxide. And in the lecture 48, that was Danishevsky's total synthesis on Taxol, where he discussed the application of Korey-Chaykovsky reaction and Heck reaction in the total synthesis of Taxol by Danishevsky. And this total synthesis was completed in 1996. And the most rewarding aspect of this synthesis was the ability to start with Whelan-Mischer ketone. And the last lecture, lecture 49 of Taxol, was Wender's total synthesis, which was completed in 1997, where we saw an enantioselective total synthesis of Taxol by Wender starting from verbenone, an efficient stereo control synthesis of a highly versatile taxane precursor which provide concise access to Taxol. And this strategy provides Taxol in the enantiomeric form in 37 steps from verbenone, the air oxidation product of pinene. And the key reaction was fragmentation of an epoxy alcohol, photochemical 1,3 alkyl shift. And then he is also using Crabtree's catalyst in this total synthesis. And this total synthesis was completed in 37 steps, and this is the shortest total synthesis of that time. So that was about the discussion on the week 10 lecture contents. So maybe you can go through that for a couple of minutes, and then we will continue the discussion on the next assignment, that is week 9 assignment. I think. Sorry for that. Here there is some issue with the network connection. Yes. So I think I have to share it again. Okay. Now we can go through that for some time and then we will start the discussion on the next week 9 assignment content. Okay, now we will start our discussion on week 9 assignment. So the first question is identify the major product in the following transformation. This compound upon treatment with this sodium methoxide and this BH3SME2, what will be happening, and out of this four options, what will be the major product in this reaction? So here, what is happening is, by treating with the sodium methoxide in the first step, this nitrogen lone pair will attack the carbonyl carbon center, and it will form the six-membered ring. So this nitrogen lone pair will go and attack this carbonyl carbon center, and here we will get 1, 2, 3, 4, 5, 6. A six-membered ring will be formed, and then this complex, this being a Lewis acid, it can interact with this oxygen, and that will help in the elimination of this CO group, and that will give us this product. Then that is in this reaction. Then if we are treating it with 6 normal HCl, this acetonide also get deprotected and we will get diode. So up to here it is asked in this question. So the correct answer is option C. That is, first this sodium methoxide will help in the cyclization, and this BH3SME2 will help in this elimination of this carbonyl group. So I hope it is clear. Moving to the next question, what is a major product formed in the following transformation? That is, this particular compound upon treatment with this sodium acide in DMF and heating to 70 to 100 degrees Celsius, which will be the major product in this reaction. So here, upon treatment with this sodium acide, this O group will be converted into this N3 and we will get this intermediate. then it will not stop at this stage. It can undergo 1,3 dipolar cycloaddition to get this 5-membered ring, that is this triazole kind of compound, and then nitrogen extrusion from this compound will result in this particular product. So the correct answer will be option A. So that is what is happening in this reaction. First autosilate getting converted into N3 and then 1,3 dipolar cycloaddition followed by this nitrogen elimination will result in our product, that is option A is the correct answer. Then the next question is identify the major product in the following transformation. That is this particular compound on treatment with this benzyl bromide in the first step and in the second step with NaBH4, which will be the major product in this reaction. So here what is happening? First, this benzyl bromide will protect this nitrogen, and we will get this particular compound, and subsequently two reduction of this imine bonds will result in this compound. That is option B is the correct answer. So benzyl bromide is used for the protection of this nitrogen, and NaBH4 is used for the imine reduction. Two consecutive reductions will result in this option B as the major product. Moving to the next question, which is the major product formed in the reaction given below? That is, this particular compound upon treatment with MCPBA, which will be the major product in this reaction. So here, as we know, MCPBA will be helping in the epoxidation of this alkene. So this alkene, more substituted double bond, will be getting epoxidized. So correspondingly, we will get this, and this will be directing this epoxidation, and we will be getting this epoxide in the alpha side, that is below side. So option A will be the correct answer of this question. Moving to the next question, identify the major product in the following transformation. That is, this particular compound upon treatment with this KOH and first step and chromium trioxide in the second step, which will be the major product obtained in this reaction. So here what is happening? First, under KOH condition, this acetate group will be hydrolyzed and here it will be OH. Then under chromium trioxide condition, it will get this double bond will migrated to here to form this CrO3 will oxidize this alcohol as well as this alcohol. So we will get the corresponding ketone here and ketone here, and this oxidative transposition will take place. That is, more stable alpha beta unsaturated double bond will be formed. So this KOH will hydrolyze this ester, and this chromium trioxide will oxidize both the hydroxyl group, and migration of this double bond will take place to get this progesterone. Moving to the next question, identify the major product in the following sequence of reaction. That is, this compound upon treatment with this particular compound and this BF3 etherate, what will be the major product of this reaction? So here, first through this carbenoid intermediate, this alkene, this particular position will be attacked by this group, and it will get this kind of intermediate will be forming in the first step. That is, this hydroxyl group will be attacked to here O, and this the carbon, and then this allyl group, and then the C6H613. Then as a result of the elimination of this N2, a minus charge will be there at this carbon, and that will attack this double bond, and double bond will shift to here, and this bond will shift to here. So we will get this as our major product. So here the correct answer will be option D. So first through this carbenoid intermediate, this intermediate will be forming in the first reaction, and then this BF3 etherite mediated rearrangement will take place to get this product. So option D will be the correct answer for this question. I hope it's clear. So there are four more questions remaining in the week 9 assignment. Maybe we can continue our discussion on the remaining questions in the next class. Now I will give you some time to go through this questions which we discussed today, and then we will be winding up the class. So I hope today's session was helpful for you all. So the next four questions of this week 9 assignment will be discussed on the next lecture. So thank you for listening and thank you for joining. So we will be winding up today's session. Let's meet on next Sunday at 3 p.m. Thank you so much.